Are you tired of your difference node cutting out more or less than you want just because that is the bounds of the points and you'd rather have it be actually based on the collision? Well, you actually can do that in PCG. And the result is this right here. Look at that. We have just around this 1 point are we actually cutting out. And I didn't modify the bounds. The bounds of these things are still all correct. And you can see they're following the shape of this actual piece. And to show that it is not just that this is very rectangular, if I change it to a cylinder, it will follow the contour of the cylinder. And if we look inside, there's nothing there. So just like that, you can see it is following quite nicely. So let me show you how to do this to level up your precision in your PCG graphs. There's a few other little tips and tricks that I've picked up on the way. So we're going to be a relatively simple video as I am currently traveling for the holidays, but nevertheless, hopefully you enjoy. Now, because this is a tips and tricks video, I'm going to assume that you know at least the basics of PCG. If you're unfamiliar with it, I recommend checking out my Getting Started with PCG video, which I'll link in the card up here as well as in the description below. But assuming you know kind of the basics of PCG, hopefully this helps you out. I'm going to get started with just a big points grid. This is literally just a create points grid set to 4,000 by 4,000 bounds with cell size just set at 50. I'm scaling the points to 0.25, and then right now I'm just spawning some regular cubes here just for demonstration. The main thing about collisions is you can either know the mesh before spawning it, in which case you can modify things before spawning the mesh. So place it where maybe it would fit, or prune it, or you can grab it after spawning it, in which case you have the mesh there, so you can use it then to cut things out for other things. I'll go ahead and set up the meshes beforehand, and then I'll show you both scenarios. To add a mesh is quite simple. Under graph parameters, we'll just go ahead and add a new parameter here. I'll click the little capsule here and I'll type in static mesh and grab ourselves a static mesh object reference. And I'll hit the drop down here and change this to an array. And I'll press F2 to rename it and I'll call this meshes. And then we'll just add two parameters in here. I'll add the PCG tree and a PCG boulder. Now, if I want to assign these randomly, I can just go ahead and grab it, drag it out, and then use a match and set attributes node. And this will randomly assign all the points to have either one or the other. Now, if I drag it all the way through, right in the static mesh spawner, I can change this to by attribute, and the attributes that we called it is meshes. So we'll call it meshes here, and you'll see there's all of our trees and our rocks. Now, it's doing that to every single point here. So in our case, we want to have far fewer trees and rocks. So let's go ahead and prune them by using a select points node. I'll keep something really small like 0.005, but I'll also use a transform points node to then offset them. Let's offset them to be minus 500 in X and Y to 500 in X and Y. I also have them randomly rotate between 0 and 360 degrees on the Z axis, and maybe randomly scale between 0.8 and 1.2. And now if I rehook up the static mesh spawner here, it's a little bit better here. We have far fewer trees here, far fewer rocks. Maybe we can use a little bit more, but now we can play around with how many there are spawning. So let's say that would be how many we want, just so we can visualize things easier. So now let's spawn in a bunch of grass and use these for cutouts. So the original positions that we had, right, is where we'd maybe want to spawn all the grass. So we would use just a difference node normally, and we can go ahead and cut out the static mesh spawner here, and here on the difference, we would set it to binary, so it would cut out all the static mesh spawner stuff, and then we can use a regular static mesh spawner, and on this one, we can just add in a seedling here. So all we're doing is spawning a seedling where all our rocks and our trees do not intersect. That kind of gets us this graph. Now, it is clearly not dense enough for the amount of leaves and everything we have, and everything does appear small, but that's all because I'm still keeping this transform points here. I'll go ahead and remove this transform points. I don't want to scale it here. I only want to scale it where I need to afterwards. And now we can see there's our actual result with the properly sized trees. And yeah, this is pretty much what we expect. We have a ton of area around every point, just completely cut out. This doesn't follow the rocks at all, and it just doesn't look good. So let's actually fix that. And you know what? It's very simple to fix. It actually requires a single node. After the static mesh spawner, I'm going to just drag out and search for collision. And there's a node called create collision data. And we just use this node after the static mesh spawner and plug that into the differences node. And all of a sudden, look at that. The collisions now remove just around these points. Well, that's a lot better, isn't it? Now, if I take a look at the original points, the match and set attributes here, if I press D to debug it in the viewport, you will see that's the size of the points. They're quite large, which is also why some things are getting cut out more than the should be. So right before the match and set attributes, I'm going to add a bounds modifier. And on this bounds modifier, just like we had for the transform points, I'll just scale it down. This one I'll scale down to 0.5 on all axes. So they're half the size. So effectively, we've made the cell size in 50 unit increments, but we've told it, you know what, but the bound should be half of that. So if I was to debug the bounds modifier, you could see the actual square now is a little bit smaller than the leaves. You can make it exactly the same size, but honestly, I feel like if there's a tiny bit of overlap, it's fine. The main thing is now you can see this fits so much nicer here as well as around the stones because far less things overlap. If you take a look right here, I'm having it at 0.5, and if I modify this to be 0.4 bounds, right, it is now fitting a little bit more. So depending on the size of your pieces that you want to do, the bounds here do matter. You can see now these fit inside of these locations because that's where the collision is. And at 0.5, they do not fit. While more accurate to the shape, right, it stops it from spawning right there because it is intersecting with a collision. Now to make this a little more natural, of course, let's go back to our graph and add a transform points here. This is going to be just for the little grass here. So now we can just rotate them around only 360 degrees. And before the difference node is when we want to do the offsets. So if you do any offsets, do it before here. So if I want to, for example, have them randomly be -20 to 20 in X and Y, I want to do that before I cut them out. And now you can see again, it goes right up to where they need to be, but it doesn't intersect into these. Well, seedlings are never inside of these poles. Right over there, where again, it's just because the square, as I showed, it's just a tiny bit smaller. But something as small like that, I'm okay with. So now that we have that, the other thing I want to take care of is self-pruning. Because this stuff is all great, but there are times when it's kind of overlapping itself. And I want to do self-pruning, and you can actually do self-pruning based on collisions. Just one thing to keep in mind though with all of these collision stuff is it is more expensive computationally compared to doing just points. But if you're not doing runtime stuff, it's free anyways. So keep that in mind. If you're doing runtime stuff, you might want to maybe not have that much collision-based computation, but if you're doing something for just an editor where you just have it be created, then it should be fine. And I'll show down the line that when it's in editor, it does not automatically regenerate when you hit play. So stay tuned for that. To adjust the self-pruning here, we would need to do that, well, right here, because this is what's overlapping itself. So what I'm going to do is after this transform points, but before the static mesh spawner, I'm going to add a self-pruning node. Now, immediately you will see that this has not changed one bit. Why is this not changed one bit? That's because the bounds are not correct. They're not set to this. Now, you can absolutely do a bounds from mesh here, and I can plug this all the way through, and I can tell it that the mesh attribute that we want to use is meshes. And now when I debug this, you can see there they are overlapping, and so it makes one disappear. But that's the thing. It is overlapping quite a lot for the trees, right? That means within these large trees, we would never have a rock that is close by, or it would remove a giant tree as it did here because it intersected. Well, I don't even know what it intersected, but it's gone. But clearly something got intersected. Maybe there were two things there. If I disable the self-pruning, you can see that was the tree, and clearly it thought somehow this is intersecting something and has killed the tree. It's not great. So I want to use collision-based pruning here. So I'm going to get rid of this bounds from mesh, and I'm going to plug that back through. And in the self-pruning node, there is a use collision attribute here. If I go ahead and enable that, I can specify the collision attribute. So in my case, it is meshes. Again, it's the same one that we added here. And you might notice, well, that's still overlapping. What's going on? It seems like this specific checkbox takes whatever's the smallest. If you have really tiny bounds and your collisions are bigger, it will use the really tiny bounds. But if you make your bounds super large, it will use the collisions. I don't know why this is, but it seems like that's how it works for my testing. So after the transform points, if I did a bounds modifier and I scaled the bounds here to, let's say, 100x in all axes, so just 100 everything, which makes them absolutely massive. If I press D on them, right, they're absolutely massive. They cover everything. But if you take a look, well, I mean, that looks pretty good. Look, there's stones right next to this tree. Well, that's never happened before because we couldn't do that before. There's actually a far more stones here in general. Well, that's looking pretty nice. So now each one of them will not intersect with each other based on collision. Now, these are very close. If I go unlit, you can see they're very close. But again, they're using their collisions, so they're far more accurate in terms of their overlap. And what we can do is we can press A on the static mesh spawner. And you can see here we have 204 entries. So there's 204 pieces here. If I go ahead and disable the bounce modifier and turn off the collision data, you can see we have 226. So by default, we actually have slightly more, but then it's not overlapping. And if we re-enable the bounds modifier and make it a little bit bigger, just by like, let's say 10, we cut out way too much because in this case, the trees just take up so much room that they kind of kill all of the little rocks around them as well. So by keeping the bounds modifier at 100, self-pruning on use collision attribute, it will take then the smaller bounds of the actual things and then use them for the pruning. Now, if you want to preview this, what does the actual collision look like? You can do it here. Unfortunately, if I pressed A here, you would see the actual bounds of everything after the self-pruning. But if you pressed A on the create collision data here, this is actually the collision information that it's using. Now, I don't know why you can't preview it on the self-pruning node, but even though you can use the data, that doesn't really matter, to be fair. But here, this create collision data does show it to you in the data viewport. So you can see all the trees collision is just a big pole, and the rocks have a little bit more collision information, and that is what it's using for all of the parts where it's cutting out. And so we get a quite nice result here. Nice and simple. Single node, single option, very easy to use. The next two things are actually tips for debugging. So when you're running into some kind of issue, these are for that. The first thing is you can visualize your attributes in the world. What do I mean by that? Well, if I right click, I can search for visualize, and there's a debug visualize attribute node, which is very handy. So if I, for example, plug it in right after the static mesh spawner, and on this visualize attribute, I can tell it which attribute do I want to visualize. Well, let's visualize the meshes attribute. Now, it gives us options for a prefix. Do I want to see the index of it? Do you want a prefix with the attribute name? I can tell it to be somewhere else. I can tell a color, a duration of it, how many maximum amount do I want to see, and whether it's enabled, of course. And if I look in the world now, this is what we get. We get every single one of these points now has the prefix of the index, and this is the path. Now, you just saw it disappear. That's because it has run out of time here. So this is really handy for debugging because you could tell to just show me for 5 seconds after I click generate so I can quickly look at the values, and then it goes away and doesn't get in your way. So for example, if I set this to be 5, it'll immediately regenerate, and then this will all have the information. There's our points, there's the information, and there it goes away. And now I'm like, okay, that seemed like it was correct. Or if I wanted to, I can make this 60 seconds. I'll see the information for much longer. Now, in this case, it is kind of a blue color, and there's a lot of green here, so it's very hard to see. So we can go ahead and just change this color to, let's say, orange. Makes it a little bit easier to see now. I can see there's the path. Okay, there's the 40th point, 41st, etc. And now I can find the information about each one of these and see maybe one of them is actually misbehaving, which meshes it, or I can even go as far as going to see the point information for the position. So I can specify, for example, position here. And now I can take a look and, okay, this point is right here. That is right there. So now if I want to, I can be like, okay, you know what? I actually don't want any points past this location. I can look at the value and be like, okay, you know what? I don't want any points, let's say past 3300 in X. And I can go ahead and make a filter for that. So it's very handy in that regard. And of course, you can enable and disable it here, or just press E on it to enable and disable the node. So it's very nice to be able to control this duration and the values you preview. And it completely works in editor. But if you want something to check if it's generating at runtime, there's a print string in PCG. And the print string is really nice when trying to figure out if your graph is even properly generating or anything is working when you want it to. If I add a print string right here, we can plug in our points all the way through it. So if it ever goes through here, it will go into the print string. And in here, we can tell it to print something specific by putting it into the print string, or we can plug that through into the print string here. I'll just type in a manual one called generating. We can display it on the node. We can print per component. So if you had multiple components in the world, it would print for each one or just once. I will enable print to screen though. So that way we'll see it on screen. And then by just having generating and print to screen, if I was to hit Alt S, I would start simulating, but nothing has printed. See, nothing in the top left. The reason nothing has printed is because it hasn't generated. So it hasn't run the graph. We already generated the graph in editor. So if you're not generating this in editor and you're generating it on runtime, then that would run and you would see it in the graph. What I mean is if I just take all of this, come down to the PCG component and hit cleanup. And by the way, I'm on generate by load. I'm not even doing generate on demand. So now if I hit Alt S to simulate, it will generate everything. And in the top left, there's our component information generating. So I know it has run this information and has run the print string. We can go back to our print string here and we can make a few customizations, including changing the verbosity. If I change this from log to error, and then once again, press Alt S to simulate it, it will once again generate everything on load because it wasn't already loaded. The main thing that does is if we go down to the output log and I scroll all the way to the bottom, there's our error. Because we specified error, it is in red, and there's our generating, which means also I can go ahead and go to filters, select none, and there's our generating error that we've specified. So if I want to know if something fails or succeeds or whatever it is, I can make it red like an error, or I can make it a warning by changing this error to warning, or just tell it to be a log. We can also just tell it to not do anything, just display it in the world by setting to no, and it'll just do the print string in the world. But again, if I go to the PCG component and hit generate, so it's generated already in the world, you can see it has printed it even in editor. I'm not simulating right now, but it has printed it. Again, clean up, generated, it prints even in editor. If I now wait for it to go away, there it goes, it's now gone away. So now if I hit Alt S, because it's already been generated, even though I'm simulating, it is not reprinted because again, PCG does not do any additional computation after it's already been created, which is great. By using the visualize and the print string, you can really test and see things both at runtime and in editor to make sure things are running and not running. And then of course goes hand in hand with just pressing A to see your point information or D to visualize your points in the viewport. But those are the main tips and tricks I got for you for this time. I hope you all had a fantastic and a Merry Christmas, or just hopefully a few days off if you don't celebrate it. And there's not much to this, but if you'd like, the project files for this will be available on Patreon, where you can join these wonderful people here who support what I do. It really means a lot. And if you'd like to join the community, the link to which will be in the description down below, as always. And if you want to learn more about PCG, check out this video right over here to start using it to make awesome things.